This is the video that is over stretches and compressions. This is the A part. If A is greater than 1, it is a stretch. It's vertically stretching the graph. It will make it steeper and skinnier. And I'm talking about the absolute value, y'all. So if the A is less than 1, it's compression. It'll make it fatter and wider. If I have a negative sign in front of the A, that will be a reflection over X. And if I have a negative sign on the inside of the parentheses, like this, if my negative sign is here, that is a reflection over Y. So on the outside, reflect X. On the inside, reflect Y. And outside starts with the letter O and X. That makes a word ox, because it's reflecting X. Okay. Let's take a look. I'm not going to do the warm-up with you on the video. We'll do that in class. All right. Now, I took and I sketched the parent. I didn't sketch the parent graph, but I put the parent graph points in black. And remember, parent graph, you got to point at 0, 0, 1, 1, 2, 4, and then negative 1, 1, and negative 2, 4. So that's your parent. And then we have a stretch of 2. If you notice, it is steeper than the parent and skinnier. And I'll just kind of sketch that so you can see that. It got skinnier. That's what stretching does. Just like your body. If we were to take our body and we were to stretch it, and I made myself twice as tall as I am now, I would become skinnier. If I compress my body and multiply by a number smaller, and I do half my body, then I become fatter and wider. Same sort of thing with this. This is a stretch of 2. And notice where it's at. It's in front of the variable. So it's not on the end like yesterday where we were adding and subtracting. It's in the front and it's a multiplier. So it's a skinnier graph. And if you look on Desmos and you do Desmos, here's the parent graph, x squared. And then I do 2x squared. Notice that it got skinnier just like on the other. And it's multiplying your y's by 2. So notice the 0 multiplied by 2 is still 0. That's why it's staying there. Okay? But this point here, 1, 1, it's not wanting to do it on the green graph. But 1, 1 is right here. Okay? And then if I do the purple graph, that's 1, 2. That's because it took the 1 and the y value multiplied it by 2. That's what's happening. All right. And here I'm taking the y value, multiplying it by a half. So it is compressing everything. The original graph is in black right here. And when I multiplied the y by 1/2, then it got fatter and wider. This is a compression of 1/2. All right, if we describe this just looking at the equation and nothing else, then we would say this number in the front, this is a vertical stretch of 3. This from yesterday, this is a horizontal shift left of 1. And my vertex, remember, there is no y, so I've got a 0 over here. No vertical shift. So we have a 0 over here. And remember, our vertex is going to be opposite of this. That's a shift left. So it's negative 1, 0. If I were to type that in Desmos, you'd see it. Three times x plus 1 squared. See what it did? It stretched it. That got skinny. It moved it left 1. And look where my vertex is. My vertex is at negative 1, 0. Okay. And here's just for comparison, for you to see the comparison. Here's the parent. It got made skinnier and it got shifted left. All right, this one here is going to be a vertical compression of 1/2, a horizontal shift right of 2, and a vertical shift up of 4. And my vertex is, remember, opposite of this because this is a right shift, so it's 2, 4. So let's type that in so you can see that. Remember how to type in your fractions. You have to hit a parentheses. And then you have to scale right to get out from under the radical. Under the denominator. And then we have, I done forgot what it was. I'm terrible about that. X minus 2. Okay. X minus 2 plus 4. It's a fatter graph. It got shifted right 2 and up 4. And just so you can see the parent and just see the comparison, here's the parent. It got moved this way and up, and it also got made fatter. This here, I for some reason left it'll be on your notes. I left this slide out of my notes, and I have no idea why. But g of x is equal to negative x squared will reflect over the x. Let's show you on Desmos again. There's x squared. And there's the original one, and now we're going to put negative x squared and see how it reflected it. There's the parent in green, and it just reflected it over x. It's the exact same graph flipped upside down. And the next one, if you put a negative sign on the inside of the parentheses, that reflects y. Now, if I reflect the parent, let's get rid of this one so you can see it. There's the parent. If I reflect the parent over y, oh, sorry, I'm typing it in the exact same place. Here, we'll just do this. Here is x squared, there's the parent. And now if I reflect it over y, notice it's the same graph. See how the red and the black are in the same place? That's just what happens. If I reflect this part over y, it's the same graph. Just happens that way. But if there's a negative sign there, that is what we say. We say reflect y. That must be it. I thought I had more. Okay.